but understanding the pattern of the course that we are going to start today, will not be going into the theory part and then the numerical. What we are going to do is that we are going to pick up the numerical, और उस numerical के basis में we are going to see the theory. So it's something like reverse engineering. Looking at the type of question, we are going to discuss the relevant theories, और उन theories के मदद से आगे कोई भी नए questions उनको भी आप बहुत अच्छी तरह से solve कर पाएंगे. And believe you me, the type of discussion that we are going to do is really going to help you score wonderfully in the target area. Aaj, the topic that we have started is units and dimension. Now, the moment I start with unit and dimension, you must be thinking, okay, again, the same boring pattern. What is the dimension of force? What is the dimension of velocity? Well, we're not going to do that. Because at this particular point, I think I should assume, मुझे ये assume करना ही पड़ेगा that you are well versed at least with writing the dimension. We are not going to discuss the application of dimensions either. जैसे कि we are not going to see is it satisfying the principle of homogeneity or not. Questions like that. You know, those are straightforward questions that you have been discussing, and you know, the 1 hour that you are going to spend, that is not worth doing. तो करेंगे क्या? You know, there is a specific topic in units and dimension which, number 1, has a high degree of occurrence, probability in the examination. Number 2, that during your study, you don't give that required focus to that topic. मैं units and dimension का ही topic इसकी बात कर रहा हूँ. As I said, that is not generally discussed at the beginning, but it is very important from examination point of view. So can you guess what that topic could be? Yes, that's right. The topic is the measuring instrument. Measuring instrument में we'll be talking about the Vernier Caliper. Measuring instrument में we'll be talking about the screw gauge. And we'll be talking about the least count of these devices. We'll be talking about the zero error correction of these devices. We're going to see कि इन devices की मदद से हम measurement कैसे लेते हैं. And apart from that, there is another topic which is again very important, but I haven't seen that formally is topic पे, you know, generally discussed, and I haven't found it, and that's the famous simple pendulum experiment. जो students in topic में फंसे होंगे, now you can take a big sigh of relief कि screw gauge, Vernier caliper and simple pendulum experiment. Today we're going to do the PhD in this, of course, with regard to JEE Main examination. And trust me, units and measurement may say the help from my side for these particular topics. Baki, your effort in the regular question, I'll perfectly guarantee that this topic, units and dimension, will now going to be a very strong topic of yours. Okay, so as I had said in the beginning itself, I had sought permission because today is the first class, so I had to give a little bit of background. So let's start. The first question that I'll be starting is from Vernier Caliper. Vernier Caliper के questions में you can expect, हालांकि एक चीज मैं आपको बता दूं, JEE Main में majority of the questions they come from computing the least count of the device, and they are very straightforward question, or zara sa effort that's going to give you that positive marks. All right, so let's see what's the question here. We'll read the question, and as I had promised in the beginning, question के basis में we'll see the theory, ताकि ये जो discussion, remember it's not a question solving session alone. In this we'll solve the question, but we'll also prepare, we'll also manufacture the theories ताकि कोई भी future में नए questions आ जाए, you can easily solve those. Let's see what it is. It says that there is a Vernier caliper having 1 millimeter marks on the main scale. Now, all of you must be knowing that in case of Vernier caliper, we have two scale, right? One is called as the main scale, other is called as the Vernier scale. So let me just make a quick diagram of that. So let's say this is the main scale, and excuse me, I'm not going to draw those detailed diagram like the jaws and everything. Now we are into the nuclear preparation. Bilkul we are hitting the pinpoint. Okay, so ye hai main scale, and together we also have a vernier scale. Okay, so here is the main scale and here is the vernier scale, and the combination of the main scale and the vernier scale will be called as the vernier caliper. Now you got to understand one thing, that this is the main scale. Let me write it by MS, that's fine. And this is the vernier scale. Now vernier scale is one thing, while vernier caliper is another thing. This entire arrangement, that will be called as the vernier caliper. So just remember, the combination of main scale and vernier scale will give us to vernier caliper. Or constructionally, this is maintained. This is in the design feature of the vernier caliper, that the least count of the main scale is slightly greater than that of the vernier scale. You see, I had said in the beginning that we are not here merely for question solving. We'll solve the question and we'll generate the relevant concept. Like the concept is the least count of the main scale is greater than the least count of vernier scale. But when I say greater, aisa nahi hai ki much greater, it's slightly greater. Like say for instances, main scale ka least count agar 1 millimeter hai, vernier scale ka jo least count hai, that could be 0.9 millimeter, 0.8 millimeter, that's perfectly fine. But that difference is not kept very large. We'll not go into that part, but that's into the design feature, the specification of the gadget. Okay, so what happens is this. See, what really happens is a very interesting thing. Jaise maan lete, ye main scale. Okay, now here say this is the 0 of the main scale and 0 of vernier scale. That exactly matches. Okay, काम करते हैं. Let me just slightly make it something like this. आप देखिए. The first is ऊपर देखना, right? 0 of the main scale, and this is 1 main scale. All right. Now let me go for the second main scale. The second main scale is here. Third main scale is there, and it goes on and on and on. And when it comes to the vernier, okay, let's change the color. What should I go? Let's go with the white one. Okay, तो ये है vernier scale. आप बहुत ध्यान से देखना. Right here, you just focus that the first vernier scale, okay, is slightly behind the main scale. So ये जो figure बना रखा है, ये गलती से नहीं बना है. This is actually the design feature of the device. आप देखिए, the first vernier scale is slightly behind the main scale. Why so? The logic is this. The least count of the main scale is slightly greater than that of the vernier scale. All right? Now, apart from that, there is another issue that you need to see. As you go to the second, the gap increases. That's a common sense, because the least count of the vernier scale is slightly lesser than that of the main scale. So as you proceed further and further and further, the gap keeps on increasing. I think that's easily manageable, right? That's quite easily understood. और कुछ ऐसा भी आता है after certain time, like this would happen here. There are lots and lots, and eventually ऐसा दोबारा आ जाता है that the main scale division and the vernier scale division would exactly match. That would happen. Look, initially there is a gap, और वो जो gap है, वो difference है, वो बढ़ता ही जाता है. Like the first VS, first MS, there's a little bit of gap. Second VS, second MS, the gap increases. करते 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 एक time आ जाता है, आप ये पाओगे that the main scale division and the vernier scale division would be exactly coinciding. That happens because the gap increases, और एक time के बाद, the lag becomes one complete cycle. Like, that's a very easy thing to understand. If I would like to give you an example, मान लेते एक circular racing track है. Car A, car B, both start. Let's say car A is faster. तो शुरू में आप देखेंगे the gap widens, the gap increases. But थोड़ी देर बाद आप देखोगे again car A and car B, you would find them together. उस समय क्या हुआ होगा? Car A would have covered one more lap than as compared to car B. All right, so that would have happened. Okay, so now after that, let us try to see. What does it say? Look, let's just now bring the information very properly. It says that a vernier caliper has how much? 1 millimeter marks on the main scale. Now, depending upon that, one main scale division, that is 1 millimeter. Ye MSD, that's a very frequently used abbreviation. It's not Mahendra Singh Dhoni, main scale division. One main scale division, that is 1 millimeter. आगे देखते हैं. It has 20 equal divisions on the vernier scale which match with 16 main scale division. तो यहाँ पर क्या हो रहा है? 16 main scale division is exactly equal to 20 vernier scale division. Now, it depends on device to device. Like a general device that we use is 10 vernier division is equal to 9 main scale division. So those sort of discussion you have. Okay. Now let's see. For this vernier caliper, the least count is. Now let's see. Now the first and foremost thing is, you see, you got to write one thing, that it is given. It is given that 20 vernier scale division is equal to 16 main scale division. Now, there is no point to doubt and suspect on this, क्योंकि ये condition दी गई है, that has been given, right? 20 vernier scale division is equals to 16 main scale division. And we got to calculate the value of least count. All right. Now, I see that in my WhatsApp chat box, lots of people have already started sharing their answer. जिनको पता नहीं है number, let me write it. 9311883484 is the WhatsApp number, and you just send your answers or your queries in the WhatsApp chat. So there are lots and lots scrolling. Some people are saying 4, majority 4 कह रहे हैं, and some are saying 3. Okay, let's see, अभी decide करते हैं, not to worry. All right, let's see. So what is the formula for least count? Now, this is the formula. 1 main scale division minus 1 vernier scale division. That is the formula for the least count. Now, this is the formula. Okay, what should I write? Formula, okay? Now, you need to memorize that. Now, let's see. 1 MSD minus 1 VSD ki value, I think we can find it from there. Like 20 VSD is 16 MSD, then 1 VSD will be 4 by 5 MSD, right? That's a simple unitary method, or ये बन जाएगा 1 by 5 MSD. Now, don't worry that I took so much of time, because I'd already said कि हम बस ये question solve नहीं कर रहे. Our strategy is very clear that इस question के basis में आगे क्या-क्या questions आ सकते हैं, उनको भी we are covering. And right there, eventually 1 main scale division has been given as 1 millimeter divided by 5. So this comes out to be how much? 0.2 millimeter if my division is correct, or 0.2 millimeter कौन सा option है? 4. So I'm happy majority of the students had ticked option number 4, so that's fine. Now, for those who went for option number 3, it's a right time that you rectify it, okay? It's never a problem. Mistakes are never a problem. They are the lessons for future discussion. All right, guys, so that was about vernier caliper. Let's talk about screw gauge. Screw gauge के बारे में बात करते हैं. Okay, now here. This is another wonderful question, and this question had appeared in past year examination, but this question has lots and lots to teach. Now, what is that? बहुत ध्यान से देखना. A student measured the length of a rod and wrote it as 3.50 centimeter. Do you know one thing? This is one area where lots and lots of students get confused. Like if I say, all right, what is the difference between 1 meter, 1.0 meter, and 1.00 meter? That's a very valid question and a very, very genuine question. And trust me, guys, the concept behind this, it has a potential to raise so many different questions. और एक तो आपके सामने ही है. तो आप देखिए, I have given you 3 readings, 1 meter, 1.0 meter, 1.00 meter. Now, the big question is that, what is the difference among all these 3 readings, if the difference is there at all? Now, you see, if you don't have that deeper idea, आप कहेंगे, well, all the values are same, because you say in mathematics we have been learning that decimal के बाद जितने भी zeros आ जाए, they are not going to alter the value. That we know. But hey, this is measurement science. Measurement science में एक बहुत ही important नियम है. There is a very, very important rule. और वो rule ये है, the moment you propose a value, like the value has been proposed, that value should have 2 information. Number 1, what is the numeric value? जैसे numeric value तो है ही है. Number 2, what is the type of gadget that has been used to measure that reading? If you hadn't realized this thing, do it right now. As I said, कोई भी value laboratory से prepared होके आया है, somebody said that, well, this is the value that I measured in the laboratory. तो उस value के अंदर 2 meanings होते. Number 1, what is the numeric value? Number 2, what is the type of device that has been used? जैसे कि आप देखिए, numeric value all are same, but अगर हम least count की बात करें, the least count of this device is meter, for this is 0.1 meter, for this is 0.01 meter. अगर आपने इस बात को पहले realize नहीं किया था, do it right now. And just to see the value of least count is not difficult at all. So going forward, now you know that these 3 readings, although numerically the value is same, but there is a deeper meaning within that, right? So, एक काम करते हैं now. Now let's try to see, if you see the question primarily relies on this concept कि आपके पास एक reading है और आपको बताना है कि ये जो reading हमको मिली है, which sort of device was used to measure and to give this reading. The moment you see this reading, the first thing that you can say that, the least count of the device is 0.01 centimeter. This is the first information जो आप extract कर सकते. कैसे? Very straightforward. इसका मतलब, if I try to figure out कि which gadget, which device was used to measure, I need to figure out कि वो जो gadget है, उसका least count कितना होना चाहिए? Well, no surprise, 0.01 centimeter. आइए देखते. एक meter scale, what would be the least count? 1 meter. Okay, that's done. So, this option will be invalid. Number 2, a Vernier caliper, the 10 division in Vernier scale matches with 9 division in main scale. Okay, this is a regular Vernier caliper. इसके बारे में बहुत detailedly we have already discussed in the previous question. And आप देखिए, मेरी बात सच निकली है. I have said a given question we'll see, and on the basis of that, that will help us for any future numerical. The proof is right here. So, and main scale has 10 division in 1 centimeter. Okay, काफी ज़्यादा घुमाने की कोशिश की है, but we are soon going to decode it. बहुत ध्यान से देखिए, if you see this information, I can find that the main scale division, that is 1 millimeter. Can you see that? Because main scale has 10 divisions in 1 centimeter. Cool? We have done that. All right. Now, let's go to the next one. अगले में चलते. If I go for the next one, let's try to calculate the least count. The least count, अभी हमने कहा था, 1 main scale division minus 1 Vernier scale division. और आप जब इसे calculate करेंगे, you would find that the least count of this device will come out to be, अब ये calculation की जो जिम्मेदारी, I have given it to you, all right? Because we'll not be able to devote time for each and every option because I have lots of things to cover. Or the moment you calculated that the least count is 0.01 centimeter, you would say yes, option number 2 is my correct option. Yani, the big lesson from this story is that जो भी रीडिंग आपके सामने है उस रीडिंग के बेसिस में आप न्यूमेरिक वैल्यू तो पाएंगे ही. Apart from that, you would also have the complete idea of the device that was used. Number 3, let me help it. क्योंकि screw gauge, we are going to talk about this now short while later. तो अभी बात करते हैं, एक बार चलिए इसकी बात करते हैं. Option number 4. A screw gauge having 50 division in this circular scale and the pitch is 1 millimeter. I hope all of you know, at least आपको पता है that screw gauge, the cup and handle pattern, right? तो screw gauge में क्या होता है? You see 50, there is a circular scale जिसमें कितने division है? 50 और pitch दिया गया है, that's 1 millimeter. And all of you know what's a pitch? कि जब circular scale एक चक्कर लगा लेता है, when the circular scale completes one revolution, within that time, meanwhile, it would travel a forward distance and that is called as the pitch. Now, the least count of a screw gauge, this is another formula today. We've already done for Vernier Caliper. That is the pitch divided by CST. Now, previously we did MST, Mahendra Singh Dhoni. इसे क्या कहेंगे? Chandra Singh Dhoni? All right, so that's a circular scale division. The pitch is 1 millimeter. The circular scale division is 50. All right, so this comes out to be 0.02 millimeter. That is that value. And we know least count agar ye hai, certainly for this particular reading that we have, this device is not used. In the same manner, I give you the option कि आप option number 3 को भी verify करें. That's very important. All right. Now, screw gauge. What I saw is that अगर हम past year examination देखेंगे, out of Vernier Caliper or screw gauge, the screw gauge is rather more favorite as compared to Vernier Caliper. अब इसमें मेरी कोई गलती नहीं है. I'm just telling you the psychology of the examiner कि the partiality is more towards the screw gauge. Screw gauge से question occurrence frequency बहुत ज़्यादा है. Having that said, इसका ये मतलब नहीं है that you're going to completely overlook Vernier Caliper. Both are very important. I'm just talking about relative. क्या है ना, physics teacher हैं तो हम लोग relative concept, comparative चीज़ को बहुत ज़्यादा देखते हैं. Let's see. डरना मत figure देख के. It's a screw gauge, a regular one, और आप देख सकते हैं there's a small ball, छोटी सी ball है और इस ball का diameter has been used to measure it. आइए देखते क्या है. Now see, this is a complete package जहां पर आपको least count भी calculate करना है और साथ साथ में you also need to see the reading of the device. Let's see. What does it say? Let's go step by step. The circular scale of a screw gauge has 50 divisions. यहाँ पर है the circular division and they are total 50. अभी ये 25 को you just neglected अभी के लिए, ऐसा नहीं कि हमेशा के लिए neglect करना है. And the pitch is 0.5 millimeter. Okay, I think on the basis of this much of data we can calculate the least count. अब देखिए एक ही concept को कितने बार ज़्यादा use किया है, तो isn't it very wise कि इस concept को हम अभी जड़ से clarify करें? Because see, as long as आप prepare कर रहे everything, that's one thing. But now I have shown you the complete analysis. और ये analytics देखने के बाद अब तो आपको बिल्कुल पता चल गया that these are the topics which are of high weightage. So you need to talk about that, right? तो आइए एक काम करते हैं. Let's calculate the least count of this device. Okay, the least count is the pitch 0.5 millimeter divided by 50. You get that point? So how much is it going to be? That is going to be 0.01 millimeter. यहाँ तक भी एक complete question है. हालांकि JEE Main में probability कम है, but NEET में अगर आप देखोगे, only calculating least count is a very very important question. I know lots of the viewers may also be from NEET, right? तो आपके लिए काम की चीज़ है. Find the diameter of the sphere. कौन सा sphere? यहाँ जो है. And the main scale reading is 2. अब जरा हम reading की बात करते हैं. When this sphere is tightly fitted here, of course, circular scale को घुमा के, you could see it is right here in this position. और इस situation में आप बताइए, main scale में कौन सा division दिख रहा है? It's a second division which is being seen here, right? That is the condition. Now, after that, ये ध्यान देना, this is the second division. It's not 2 millimeter, okay? So, second division is being seen and circular का जो 25th division है, that is matching with the linear scale. Where is the linear scale? Here is the linear scale. इस linear scale के साथ the 25th division is matching. Let me tell you again, this is the second, all right? This is the second main scale, not 2 millimeter. So reading कैसे करते हैं? That's a big thing, and it's big but very, very interesting and most importantly quite simple. Reading की बात करते हैं. Second या 2 division of the main scale. So that's going to be 2 multiplied by 0.5 millimeter. अगर मान लेते least count या pitch की value 1 millimeter होता, then second division would be 2 millimeter. That's quite simple, right? तो अभी आपने क्या लिखना है? The reading as per the linear scale. The reading as per the main scale. And plus, there's another interesting thing. 25, ये 25 क्या है? 25th circular scale division is matching with the reference line. You get that point? 25th circular scale is matching with the linear scale. अगर 38th होता 30, 26th होता 26, इससे ज़्यादा आसान चीज़ क्या हो सकती है? Whichever division of circular scale is matching with the main, आपने चुपचाप से वो लिखना है multiplied by least count. Least count of what? Least count of the screw gauge. Not the least count of the circular scale, not the least count of the main scale, the least count of the entire apparatus. और इसकी value हम already calculate कर चुके हैं. How much is that? Oh, here 0.01 millimeter. तो आइए इसे करते हैं एक. This is going to be 1 millimeter plus 0.25 millimeter, and how much would be the reading? Option number 2, right? इस बात को लेके बिल्कुल परेशान मत होना कि सर ने यही क्वेश्चन सॉल्व करने के लिए he took 5 minutes. My purpose here is, on the basis of a question here, I would like to discuss some more other important things. So we have opened up all those things. We are unfolding it. और एक बार आप प्रैक्टिस करोगे ना, trust me guys, it will not take more than 30 seconds. और भी है screw gauge. मैंने पहले ही कहा था, my research says that out of Vernier Caliper and screw gauge is comparatively more important. एक गलती या I don't say mistake, एक psychological चीज कि length of question देख के आप घबरा जाता है, वो मत करना. शायद इसी आदत के कारण से lot many students have missed quite valuable marks, all right? Okay. A screw gauge with a pitch of 0.5 millimeter and a circular scale with 50 division, okay, यहाँ हूँ मैं, is used to measure the thickness of a thin sheet of aluminium. That's perfectly fine. Yani on the basis of the first line, we can calculate the least count. Okay, thoda sa I want to manage my space. All right, now let's see. Solution. The least count, that is going to be. अब देखिए यही जो least count है, so many times it has occurred. So it's giving us a clear idea. 0.5 millimeter, 0.5 divided by 50 millimeter, and this is going to be 0.01 millimeter. Okay, thank you very much. यहाँ तक का जो information है, इससे हमें least count calculate करने में मदद मिली है. All right. Now, there is another twist in the story, guys. Before starting the measurement, it is found that when the two jaws of the screw gauge are brought in contact, आपको पता है अगर कुछ भी नहीं है, like in the previous example there was a sphere, वो sphere नहीं है and you tight it, okay, you keep on tightening, nothing is there. There's something happening. The 45th division coincides with the main scale line. होना क्या चाहिए था? When no device is there, like no sphere is there, किसी को भी measure नहीं करना है, the zero of the circular scale should coincide with zero of the main scale. It's something like, आपको मैं एक बहुत खतरनाक डिवाइस के बारे में बताता हूँ. क्या है? Weighing machine. चढ़ने से डर लगता है, राइट? दोनों ही केस में क्या पता ज्यादा आ जाए, क्या पता कम आ जाए. So if there is nothing on a weighing machine, तो reading क्या आनी चाहिए? Reading should be zero. Exactly in case of a screw gauge as well. If there is nothing, when it's properly tightened, the zero of the circular should exactly match with zero of the main. But ऐसा नहीं हो रहा है. ऐसा नहीं हो रहा है. और क्या है? The 45th division coincides with the main scale line and the zero of the main scale is barely visible, यानी दिख नहीं रहा है. So it's a clear case of negative zero error. This is a clear condition of negative zero error. इतना कस दिया हमने, the zero of the main scale that is completely hidden. Okay, so it's a case of negative zero error. Now we would be interested that how much is the error. Error की value एक बार निकालते. Just have a simple look. It's something like, मान लेते एक weighing machine है. Suppose there is a weighing machine. Before anything is kept, जो भी reading आती है, that reading would be the zero error. But in case of screw gauge, there's something more that you need to understand. And I'll just give you a good example. Weighing machine के example लेते. Suppose this is the scale of the weighing machine. जिसके ऊपर आप चढ़ते हैं, then you see something goes there. The calibration जिसको कहते हैं, जहाँ से आप reading देखते हैं. Now let's say that this is 0, right? That's how it goes. और जैसे हम चढ़ते हैं, मान लेते हैं ये clockwise घूमता है. So this would be 5 kg, this would be 10 kg. करते 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 करते, let us say this is 95 kg. इसका मतलब आप बताइए, ये जो weighing machine, how much total weight can it measure? It can measure up to 100 kg. 100 kg से ज़्यादा वो नहीं कर सकता. Now, why did I take such sort of circular one? I think you could understand. जो meter scale, जो not the meter scale, जो scale जो घूमता है, once a certain load is kept, I'm talking about that. बहुत ध्यान से देखना. And here's the pointer. Now here is a very tricky thing. Imagine when nothing was kept, this pointer was showing 5. When nothing was kept, the pointer was showing 5. तो आप बताएं, how much is the error? The error is the 5 kg. वो extra दिख रहा है. But this is a circular one. So far, it's perfectly fine. But let me go with the next case. Imagine when nothing was kept, 95 was seen. इसका मतलब error 95 नहीं है. आप बहुत ध्यान से देखना. 95 दिखने के लिए, how much additionally it has gone? It has gone additionally only by 5 kg. So this is the small mistake that generally happens in circular scale. और examiner को इस बात बहुत अच्छी तरह से ये बात पता है. That's the reason why time and again वो कहीं ना कहीं से negative zero error के concept and the question based on that they find it. So just try to see here, the total circular scale is 50. So you were tightening it. 0 has gone further and 45th division of the circular is matching with the main scale. So additionally, how many divisions did it travel? Additionally, it traveled only 5 divisions. You get that point? So you need to understand this thing. So that particular error is equals to that particular class. Okay, I have message from there. I think if you can write your name properly, Sanusoni, that's the name there, I can see. Yes, the class started at 1 and it's a special crash course series for JEE Main, and today was the first class for physics. If you joined late, physics a bit late, but chemistry and maths, they are still there. So welcome to the class. All right, now let's come there. Zero error, that's going to be minus of 5 multiplied by least count. All right, now why 5? That has been clear, and that is minus of 0.05 millimeter. So this has been done. Okay. So up until now, on the basis of information so far, we could extract this many information. Are we going to have class every day? Yes, except Sunday. Sunday is the chutti day. So today is the first class. Monday to Saturday, right? 1 to 4. 1 बजे से लेकर 4 बजे दोपहर को. You would find that. Okay, any other information? I don't think so. Okay. All right, let's see now. So zero error, we got minus 0.05 millimeter. Now let's see. Now the first thing is, see, there is another thing that you need to understand, and that is called as the zero correction. वैसे देखो, if you have a little bit of idea, जो error है उसे आप आसानी से compensate कर सकते हैं, but ये science है. Everything needs to be defined very formally. So zero correction by formula is always negative of zero error. And trust me guys, बस यही एक information एक बहुत important question बन के आता है, and it has come. So you know, these are equally important for JEE Main and NEET aspirant, although primarily we are doing it for JEE Main, but even the NEET aspirant can take maximum benefit from this. And this is the formula. Zero correction is negative of zero error. So how much is the zero correction? That's going to be 0.05 millimeter. That's great. वैसे mentally you know कि अगर error negative है, in order to compensate you need to add that value. So that's quite simple. आगे बढ़ते. What's the thickness of the sheet if the main scale reading is 0.5 millimeter? Okay. Now let's go with the reading. Main scale, that is 0.5 millimeter. इस बार division का चक्कर नहीं है, unlike the previous question. It's straightforward 0.5 millimeter, right? And 25th division coincides. So plus 25 multiplied by least count. That's straightforward. This would have been the complete answer, जैसे हमने पहले किया था. But our gadget is a faulty gadget. It has an error. और वो error को कैसे compensate करे? Plus zero correction. और believe you me, ये भी एक बहुत important question है. Zero correction. It is always added. Zero correction is never subtracted. Addition and subtraction, it will automatically take care. अगर zero correction negative है, तो यहाँ रखोगे negative value, that would be subtracted. But as a formula, zero correction is always added. Okay. Now let's see. This is going to be 0.5 millimeter plus 25 multiplied by least count. How much is that going to be? 0.25 millimeter, or zero correction is 0.05 millimeter. I think we are done. So this is going to be 0.80 millimeter. Guys, you don't know what an important piece of information that we have solved. I have seen hundreds and hundreds of students fumbling and getting confused when it comes to calculating the reading of a screw gauge with zero error, and we have done it successfully. Okay, बस एक बात ध्यान देना, वो circular scale है, वहीं पर मुझे थोड़ा सा डर है, but I have already explained it in a very greater detail that 50 divisions था, तो 45th match हो रहा है, तो additionally only 5 divisions have gone extra. All right, some more screw gauge से देखते. Okay, this time I know I'm pretty confident that you are certainly going to manage it. आइए देखते, आराम से करते, डरना नहीं है. डरना मना है. That's a big thing. लॉट मेनी टाइम्स क्या करते हैं ना, ऑलरेडी आप नेगेटिव साइकोलॉजी में होते, स्क्रू गेज, वर्नियर कैलिपर, एंड द मोमेंट यू सी अ बिगर क्वेश्चन दैट ट्रिगर्स यू, आप कहते हैं छोड़ो इसको, हटाओ, लेट्स नॉट डू दैट, दिस इज अ वेरी इंपॉर्टेंट वैरायटी. ऑलराइट, लेट्स सी. The pitch and number of divisions on a circular scale for this is 0.5 millimeter and 100 respectively. Step by step, we are going to dissect, chop, 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 chop. First chopping, that allows us to calculate the least count. क्या करें, इसे solution लिखें? Alright, so the least count of the gadget is how much? 0.5 millimeter divided by 100. Now, decimal के बाद divide करना, I find it very interesting by taking decimal tut, tut, tut. That's how we are being taught in the school days, right? So, good old days. So, 0.005 millimeter. काफी कम least count है, not a problem. आगे देखते. When the screw gauge is fully tightened, यानी कुछ भी नहीं है, fully tightened किया है, weighing machine के ऊपर कुछ भी load नहीं है. Without any object, the zero of its circular scale lies 3 division below the reference line. यानी कुछ ऐसा है, आप देखिए ये है मेन स्केल या लीनियर स्केल और सर्कुलर स्केल यहां है, सर्कुलर स्केल के 0 यहां है, 3 डिवीजन नीचे है. पुराने केस में क्या था, this 0 had gone up, surpassed the reference line. इस बार 0 of the circular scale could not reach and 100% 0 of the main scale would be visible. That's how it happens. अगर ये 0 ऊपर चला जाता है, आप देखिए अगर ये 0 exactly यहाँ फिट होता रेफरेंस लाइन में, तो this 0 would be just visible. अगर ये और ऊपर चला जाता, in that given case, what would have happened? This 0 would be invisible and that would be the case of negative 0 error. This 0 का मतलब 0 of the main. So clearly this is the situation of positive 0 error. So the 0 error, that's going to be plus or kitna? Let's see. 0 of the circular scale lies 3 division below the reference line. So plus 3 multiplied by least count. That's how it goes. और least count की value वहां पर है, so that is 0.015 millimeter. Hey guys, now how much is the zero correction? एक काम करते, इसको ऊपर बढ़ाते, okay? The zero correction, that is negative of 0 error. Let's not write that formula again. So this much is the zero correction. This much is the zero correction. अब चलिए reading की बारी. The readings of the main scale and the circular scale for a thin sheet are 5.5 millimeter. So reading, let's call it as R. Main scale is 5.5 millimeter. आगे देखते हैं. And 48. So that will be 48 multiplied by the least count 0.005 millimeter. Or zero correction is added, but eventually minus 0.015 millimeter. And when you do that, option number 3 is going to be your correct option. That's how we do it. The calculation part, you can easily handle it, but the whole idea behind 0 error, the correction, positive 0 error, negative 0 error, that is very much important. All right. Now that was about vernier caliper and screw gauge. जैसे कि क्लास के शुरुआत में मैंने आपको कहा था, that there is another experiment which is important in examination, but people generally don't give that much attention during study, and that's the simple pendulum experiment. देखते आइए. Simple pendulum experiment में एक चीज है that really creates a big trouble. आइए इसको एक बार अंडरस्टैंड करते, आराम से इस क्वेश्चन को ठीक से समझेंगे, you will be able to solve everything. Look, in a simple pendulum experiment for determination of acceleration due to gravity, okay, yani what formula would be used? Time period is 2 pi under root of L by G. एक कहानी है, उसे आप समझ लीजिए. I'll guarantee simple pendulum question is yours. कब भी आ जाए, you would be more excited to solve. Let's see. अब जरा ध्यान से देखना. time taken for 20 oscillation is measured by using a watch of 1 second least count. सबसे पहली बात, टाइम एक चीज है, टाइम पीरियड अलग चीज है. Now what is this? I'll just give you with the help of an example. मान लेते there is a second pendulum, यानी जिसका एक चक्कर का जो टाइम कितना होगा 2 seconds. So that 2 seconds is the time period. But क्या आपको लगता है कि while measuring the time in the laboratory, you just do it for one oscillation? No. For variety of reasons which I don't want to share, बस एक oscillation के लिए नहीं करते. People allow it for 5 or 6 oscillation. So imagine I take 6 oscillations. और 6 oscillations के लिए ideally आना चाहिए था 12 second, but with little bit of errors and everything, response time, blah blah blah, मान लेते 12.1 second आ गया. So 2 second is the time period. 12.1 second for 6 oscillation, that is the time. So laboratory में जो हम measure करते हैं वो time period नहीं करते, we do for the time. और उस time को number of oscillation से divide करके we calculate the time period. तो यहाँ ध्यान से देखिए, the time taken for 20 oscillations, okay, the number of oscillation that is 20 is measured by using a watch of 1 second least count. Okay, now let me just give you the relationship. T equals to N capital T. N is the number of oscillation, T is the time, capital T is the time period. अच्छा ये मत कहना कि ये small case है तो इसके value कम होगी. That's a very childish way of understanding. Of course, small t will have a larger value, isn't it? Because this is for more number of oscillation. All right. Now, do you know one thing? ये जो 1 second है, this is delta small t. This is one of the biggest blunders of the century people do. कि वो जो clock का जो least count है, they say that's delta capital T. No, my dear. क्योंकि हम जो measure कर रहे हैं, वो time कर रहे हैं. We take it for number of oscillation. So, the least count of the watch is the error in the time, not in the time period. You get that point? इसे ध्यान से समझना, okay? And the mean value of the time taken comes out to be 30 seconds. Okay, this has also been given that this time that comes out to be 30 seconds. All right? Okay, the length of the pendulum is measured by using a meter scale of least count 1 millimeter and the value obtained is this much. यानी length की जो value है that's 55.0 centimeter और delta L that is 0.1 centimeter. वैसे just by reading अगर ये information नहीं दी जाती तब भी we could easily guess the least count. We discussed it previously, right? But examiner दयावान है इस बार. The examiner has given you, is kind enough, generous enough. Least count is 1 millimeter. हमें निकालना है the percentage error in determination of G. अब एक चीज बहुत ध्यान से देखना है. यहाँ पर the greatest idea is here. The greatest idea is here. Delta T will be N times delta T. The entire decisive factor is here. यानी delta T by T अगर आप divide करेंगे that's capital delta T by T. Remember this is a very important one. You want one more tick? लो जी. यानी time अलग है, time period अलग है, परंतु the fractional error in the time and the fractional error in the time period, they are same. The fractional error, they are same. You got to understand that. So right here we get G equals to 4 pi square L divided by T square. अब ये question कर रहे हैं तो I properly assume that at least you know this plus twice delta T by T. लो जी, सब value आपके सामने पेश है. You put all those value and of course the percentage error has been asked. So 100%. अब ये एक value रख के calculate करके मैं कोई भी काम आपकी शान के खिलाफ नहीं करना चाहता हूँ. The calculation is quite simple, isn't it? But yes, I'll give you the answer. The answer would be option number 2. ये question अगर आप ठीक से समझ पाए, अगर की बात ही नहीं. I know you have understood it carefully. Now, any question from simple pendulum, I've given you the freedom. जाइए, पुराने question paper उठाइए या any new question and you start solving it. Just be careful. There's a difference between time and time period. There is a difference between time period and time. और बातों में मेरा भी time हो गया. Okay, so time period time and the physics time, that's completely over. So yes, as I had said in the beginning, we have started a brand new course just to help you elevate your score in JEE Main. This was day 1. The other classes are coming, and attend it regularly. You're certainly going to benefit. Thanks for joining me. Allow me to sign off. I'll catch you up tomorrow. Take care. Bye-bye.